What if you could improve your SQL skills, solve 24 real-world challenges, and earn a certificate all at once? In this series of videos, I'll be solving 24 SQL challenges of the SQL Advent calendar that was organized by the interview master. Now, this is my dashboard. I've completed it, so I'll be guiding us step by step how to tackle each and every day. So if you are a beginner, an aspiring data analyst, if you are preparing for a technical interview, this series of videos is for you. So in this first part of the video, I'll be solving from day 1 to day 6. As you could see, we have the easy, we have the medium, we have the hard problems across the challenges. So if you are new here, kindly subscribe to my channel, drop your like, turn on the notification so that you will stay notified when I drop the part 2 of the series. Drop your like and your comment. Thank you very much. Let's get right in. Okay, for day 1, we have query to run. Is there any run to find the top 10? We have to find the top 7. So every year, the city of Woodville conducts a reindeer run to find the best reindeer for Santa's sledge. Can you write this query to return the name and rank of the top 7 reindeers in the race? So basically, let's run our query to see what we have. Now run this, we'll have an idea of our table. We'll see we have the number, like we have here, the name, the rank, the color. So currently this table has been ranked, so we just want to return the top 7. That means where the rank is 1 to 7. So what I will just do, and we have to return the name and the rank. So I'll use this with name, rank, from the next line, from this. So I'm just going to do where rank. I want the where rank is less than or equal to 7. Let's check this out. Good. This is actually correct. But for best practice, I'm just going to order by rank, then ascending. So this gives us the same result. So this is our answer for the question 1. This is day 1. So we'll move now to day 2. So for day 2, we have Santa wants to analyze which toys that were produced in his workshop have already been delivered to children. We are given 2 tables. That's the toy production and toy delivery. Can you return the toy ID, toy name of the toy that has been delivered? Now we will see that we have the toy ID and toy name here. So we want this toy ID and this toy ID that was delivered, and from this toy ID we'll get the toy name of the ID. So these are the toys that was produced, these are the toys that were delivered. Now if we should do a quick count, let's do a quick count. So counting the delivered is 7. So let's see how many production we have. So we have 12 production, 7 delivery. So we want to get out the IDs that were delivered and the name. So I'm just going to need to do a join. So simply because we need to get out the toy name, and the toy name is of the delivered is not here, so we need to have a join. We need to have a left join. So I'm going to select, first of all, the production I use as P, the toy ID from production, toy ID, the toy name, sorry, the toy name. So that's something like production dates. Then we have the delivery should be D, delivery dates, yeah. So I have it from the toy production as P. So I have it left join, right? Toy delivery as T. So I'm joining them on the toy ID. That's the key I'm using to join them. So where delivery dates is not no. If we should not put this at first, let's see what we have from this. Now we could see that these are all the toy IDs that was produced. We have 12, and they come with their delivery dates, right? So now we want to return this same table where the delivery dates is not null. Is that means it's not empty. So basically, you can see that we have the toy ID 1, 3, 5, 7, 8, 10, 12. We should count all of this to amount to 7, 2, 3, 4, 5, 6, 7. So we've come to the end of this day 2. So we'll move now to day 3. Okay, we have, it said the Grinch has brainstormed a ton of prank for Oven, but he only wants to keep the top prank per target with the highest evenness score. Return the most evil prank for each target. If 2 pranks have the same evenness, the more recent brainstormed wins. Okay, this is a little tricky, so we're going to break it down actually. Now with this, I think we will need to use a subquery. Now first of all, let's get out and so firstly, we are going to create a ranking for each of the prank ideas. So the first thing I want to do, I want to check out my table. Let's check out what we have in the entire table. Let's run this. So I could see that we have the prank ID, the target name, the prank description, bonus score, and the created dates, right? So the first thing I want to do is to create a ranking for each of the prank, and I'm going to partition it by the target name, right? Target name, because this will help us to divide the grouping based on each target name. Okay, so let's have that. So I'm going to do star, and I'll have the row number. Over. So the partitioning is going to be partition by, so I'm going to use target name. Target name. Now I'm ordering by evenness score descending. right? Then created at descending also. Now let's leave this table as RON. Now let's run this. Let's see. So if you should notice, let's take this guy off. For bakery, which is our target name, 1, we have the row number 1, 2, 3. For church choir, we have 1, 2. So each target name has a ranking based on that target name. So the ranking is not done generally. So we ranked it by evenness score. So for bakery now, we have 3 bakeries. Then evenness score 875. So the highest is 8, so we have 1. The next highest is 7, 2. So same thing applies to the church choir. The highest is 9. So if we had used ascending here, we'll be having the lowest having a rank, the row number 1, right? If we use ascending here, let's try that out. You can now see that under the bakery, the lowest evenness score is having the row number 1. But that's not what we want to achieve. But based on the question, it says if 2 rank has the same evenness, the most recent, okay, return the most even rank for each target. So I think the highest should be the gets the highest and lowest row number. So we'll go with this. Let's run that again. Good. So we've been able to partition our table and get out this row number. Let's read the question again. Okay, but it only wants to keep the top rank per target. So now we want to, basically what we have seen now, we want to get out the top ranks. So for the bakery, we want to return the row number 1. For the church choir, we want to return row number 1. So all the columns, all the rows that has row number as 1, we want to return them, right? So we need to filter that out. So I'm going to hide this inside the subquery. Select, I want the rank ID. So I'm going to need to put this in the brackets. I want the rank ID. I want the target name. I want the rank description. Right, I want the evenness score. Then I want the created at. Now the reason I'm not using complete star, the star here, is because if I use that, I'm going to be getting the row number back, which I don't need. So these columns are okay for me. So from so I've already opened brackets here, so I'm going to close the brackets here. So I'm going to do where RN is equal to 1. Now let's go through our report. So let's run the code first. Let's see. Good. So what I'm returning here now is the top evenness score for each target name. So for the bakery now, this is the top. For the church choir, this is the top. Also considering that we considered the created dates. So if 2 rank have the same evenness, the more recent. So that's how we use the descending here. So descending is taken from the more recent to the more latest, right? So I think we can also solve this question. That is all. So our question is done. So we're going to move to day 4. So our day 4, Kelvin is trying to decorate the house without sending the electricity bill through the roof. So I want to write a query to find the top 5 most energy efficient decorations. That means the lowest cost per hour to operate. So first of all, I'll always love to view my table. I don't think I have a lot of data on the table, so we just view everything. So I could see that I have up to like 30 items. I have the decoration ID, name, energy cost per hour. So what we're trying to get out here is to write a query to find the top 5 most energy efficient decoration. So just continue from this. I'll just do, okay, I've already done from, I will do order by the energy cost, right? So since it's in lowest cost hour to operate, that means I'm going to need to add ascending. So let's check it out. So it's going from the lowest to the smallest, from the lowest to the highest, right? But one thing I want to know is that without putting ascending, the default, by default, what happens is ascending. So when I click on this, it's still ascending. So except I click on descending now, so the highest comes up. But we want it, I can leave it blank. I'll leave it blank. Then you just want the top 5. So remember your limits function, limit 5. So I want the top 5. So you know to get that. So these are top 5 most energy efficient decoration, the names and the IDs. So moving to day 5. So now we have a question here. Some ifs took time off after the holiday rush, but not everyone has returned to work. List all ifs by name, showing their return dates. If they have no return, if they are not returned from vacation, list their return date still resting. Okay, so we have 2 tables. We have the ifs and the vacation details. That's the day they started the vacation and their return date. So first things first, I think we will need to have a case statement here, or a switch statement. So first of all, let's select columns I want to view. Then definitely we will need to do a join, a left join. Working with the if ID, if name. So this if ID, I'm getting it from the ifs. Then the view is the vacation. Let's use view as vacation. So I want to show the start dates. Now for the end dates, okay, let's have something. Let's do the return dates. Let's try something. So from left join vacations as V, right? So I'm joining them on the E that's if ID to B that's ID. Order by, let's order by if name. So let's run this and see. Now you see that not everybody has gone on vacation actually, right? As you could see, not everybody has gone on vacation. Then those that gone on vacation, not everybody has returned. So I want to bring in a case. Instead of returning this return date, I want to return a case statement. Let's have it. A case statement. Let us check when, right? Just basically as though you're writing in plain English. When the return date is null, it's blank, or let's do a double check if the return date is equal to an empty string. Then what do we want to see? I want to show still resting, like it was mentioned there. So the other case that could happen is, that means if they don't fall under this category, that means they have a return date. So I want to return the actual return date. Then end. So the title should be return date, right? Good. Now let's run this and see. So you will see. So those that actually had return dates, their dates were showing. But those that are not returned were showing still resting. Even those that are not gone on the vacation were showing still resting. You can actually add if condition to check out, to remove those that are not gone on vacation. So I'll just do, just before the order, I'll say here start dates not null. Let's see. Good. So basically we are seeing only those that have gone on the break, on the vacation, and they are resting, and those that have returned, right? So it's a lot we could do here actually. So we're going to stop here. So we'll move to day 6. Okay, for day 6 we have sky results snowfall ranking. It says body is planning a winter getaway and wants to rank sky results by annual snowfall. Can you help him bucket these sky results into quartiles? We could use sub queries or common table expression to resolve this, but let's take the city route, since we already tackled the previous example with subquery. So first of all, let me run my the query for the entire table. Let me see what I have. Something like this. So let's run this and see. Okay, I have result ID, result name. I have the snow months. This is the months. This is the inches. Okay, let me know how many I have. Let's check how many we have. Okay, we have about 100, right? That's good to know. So let's take it step by step. First of all, let's get the results ID. Then we'll get the result name. Then I'm going to need to do a sum of the snow fall inches, right? So remember that after doing a sum, we will need to group by. Very critical. We would have to group by the result ID and the result name. Okay, so let's see what we have here actually. Good. So I'm going to give my sum a name, an alias, as let's call it total snow. Let's see what we have. Good. So now I have all of this. Now what we want to achieve, okay, for the sake of this, let's round it up to 2 decimal place. I love doing excellent job. Let's do round. I hope SQLite accept this too. Let's check this out. Good. So all our long values, they've disappeared. The next thing we want to get now is to actually now bucket these scar results into quartiles. Firstly, I want to store this in a subquery, in a common table expression. I'll call it to snow, right? As open a bracket, enter, then close the brackets. So let's check this out. Okay, I shouldn't have two names repeating. So let's rename this as annual snowfall, right? So let's run this query. Select star from total snow. So let's see what we have. Good. So we are getting the same results. So track. So firstly, I want to return. Let's just return everything that we have there. Result ID. Let's bring this guy to the next line. I want the result ID. I want the result name. I want the. Now I'm going to use it annual snowfall. Get it? Annual. Right? Now the next thing I want to use. Let's arrange this thing excellently. Let's do this and do this. So do this. There's a function called the entile. It's used for quartile. So it divides it into places. Entile. This is the most important part of this formula. So I want 4 places because a quartile is 4. If we're doing the fifth-tile, that's using 5, right? But the quartile is 4. So I'm using a entile of 4 over. So I want to order it by our annual snowfall, right? Descending, because we want to rank it. That means you have the highest to the lowest. So I'll give this title snowfall quartiles, right? So let's run this. Okay, I think we'll need to order. So let's add an order by the annual snowfall that we have, descending. So I think this should solve it. Excellent. Now, firstly, we have 100, right? And we are divided into 4. We've moved them into quantiles. You see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5, then 5, 5, 5. So divided into 4 categories. So the ones are the highest, the 2s are the second highest, the 3s are the third highest, while the 4th are the lowest, as you can see. So we've been able to help body in planning a weighted getaway because with the rank skill results now, he could be able to make some decisions that he needed to make, right? So I want us to look through the results again. First of all, we had created a table from our main table. We named it as total snow. And we got out this, adding a entile. Then we ordered it by the annual snowfall because we are checking by the annual snowfall. Annual snowfall should be the basis for ranking, and we're doing it descending. If we're working on ascending, that means the lowest becomes the number 1, while the highest becomes the number 4, right? So I think this solves question 6. So we'll wrap up this video in this question 6. The part 2 will start from the day 7 to the day whatever we stop. So I want you to stay tuned to this channel. If you have not turned on notification, kindly do so now. Subscribe to the channel, like this video, drop a comment on the questions you want to ask. Then I will drop the link to Interview Master, the Advent calendar, SQL Advent calendar, on the description and also in the comment section. So you can check it out, practice for yourself, and get certified with this. Thank you very much for watching. I'll see you in the next video.